Hi all. Today I would like to discuss about factors on which the porosity depends. Initially I would like to begin with grain size. In general, grain size comes into the play only when the diameter of the grains are different. Like it should be random. For example, if I take two grains of different dia, if it is D1 and it is D2, then it should, if the D1 is equals to D2 and similarly to all the grains, like for example Dn, then the porosity is independent of the grain size. In general, we don't come across such environment in reservoirs. In general, the porosity depends upon the grain size because we'll be having different types of grain diameters, and this is one of the factor on which porosity depends. And coming to the second one, it is grain shape. In order to say whether shape of a particular grain, we should say based on two parameters, like whether it is a porosity, whether it is a sphericity of the grain, or based on its roundness. And sphericity is again divided into two types, whether it is high spherical or low spherical. And again, roundness is again divided into two types, like whether it is angular or rounded. If I say, for example, I would like to give two examples. If I say this roundness is nothing, sphericity is nothing but it is how similar a grain is to the sphere. For example, if I take this grain, I could say that it has high sphericity compared to this. It is a low spherical, and this is highly spherical. Coming to the roundness is nothing but it is the degree of smoothness obtained due to the abrasion. Let me give an example. If I take two grains, this grain is completely soft because of it is highly rounded, because the abrasion it has gone is immense, like it has transported a lot, so that the surface of the rock got completely smooth. Once if we take this grain, the surface of the rock is completely abrased. It means that it has not gone enough transportation, or it has not transported a lot where its surface is still abrased. So we can say it is angular. It is rounded. So then how could we say how this is going to depend upon porosity? If we have grains of high sphericity, the porosity will be high. If the grains are low spherical, the porosity will be low. If the grains are angular, then porosity will be low. If grains are rounded, then the porosity will be high. And coming to the another one, the grain distribution. We can also say it as a grain sorting. We can say the distribution can be divided into two types, whether it can be a well sorted one or the poorly sorted. If the grains are well sorted, it means that the arrangement of the grains is very regular. And if we say that if the grains are poorly sorted, it means that the grains are irregularly placed, like this. If the grains are well sorted, then we can say that porosity will be high for a well sorted reservoir compared to the poorly sorted. Because, for example, if we take 2-3 types of diameters, then there are 3 grains, and if we take the poorly sorted one, the small can replace the void space in between the larger grains, causing the porosity to decrease. So we generally conclude that poorly sorted distribution has a less porosity compared to the well sorted one. As I said about the sphericity here, what is sphericity is nothing but the how come a grain can be figured out based on its shape as a sphere. And sphericity can be measured by considering an average. You can see B here, B is nothing but the average radius, and A is the sum of the radius of edges. Like for example, if I take this as x1, this is x2, this is x3, and this is x4. So on an average, all these are the edges because the surface is abrased, or you can say this as an angular and highly spherical grain. So to figure out the sphericity, we generally sum up all the radius of the edges, like if x1 plus x2 plus x3 to xn is equals to a here, and the average radius of this grain is b. So in generally we measure the roundness by dividing all the sum of the radius of edges by the average radius a by b. Here porosity, in my previous video I have said about the classification of porosity in terms of effective and ineffective porosity. Here the classification is based on the formation of a formation, means how, whether it is a primary or secondary porosity based on the depositional environment. It is divided into two types, whether it is a primary or secondary porosity. Primary porosity is also known as original porosity, and this porosity is something which we get before the compaction or cementing. For example, there is a lot of transportation and they'll get settled automatically without any compaction or any cementing. The porosity which we find automatically after the deposition is primary porosity, and once after a certain time all the grains get deposited immensely, and it undergoes a few other parameters, like it undergoes fracturing, dissolution and high sedimentation, and it causes a secondary porosity. And the porosity which we measure after a direct deposition is the primary porosity, and the porosity will be uniform. The pores will be having uniform pores, and the secondary porosity will have non-uniform pores. And in general we find such type of porosity in sandstones. In secondary porosity is very common in carbonate reservoir, because the carbonate, the lime CaCO3 undergoes a drastic change into a dolomite. The limestone undergoes a dolomite, and there are a lot of fractures, works, formation that causes secondary porosity in the carbonates. So in general, most of the secondary porosity is seen in carbonate reservoirs. Now I would like to say about the application of porosities. We can measure the porosity by using the formula like pore volume is equals to AH into 5, where A is the area, H is the feet, H is the width, thickness of the formation, A is the area of the formation, and in order to get the pore volume in feet cube, we need to take 43560 into AH5, where A is in acre, H is in feet. So it is a direct conversion, so that we'll get pore volume in feet cube. And if we have A in area, A in acre, H in feet, and we want pore volume in barrel, we can consider 7758, because 1 acre feet is equal to 7758.42 barrel. And coming to the average reservoir porosity, in general we generally come across the reservoir porosities. We generally will not have porosities similar at every height and every depth. We'll be having different porosities and different formations. So the average reservoir porosity can be figured out by checking out by knowing how the porosity is changing. If there are 5 layers like this and it is changing, like it is 5.1, 5.2, 5.3, and we can simply sum up all of this. Like if 5.1 is equals to 5.2 is equals to 5.3, if we find a few layers of a reservoir where the porosity is same but the layers are different, then we can simply take 5 average is equals to sum of all the 5.1 plus 5.2 all plus 5.3 by n. And thickness is nothing but here the height. The height of the, here height is same, not this one. H1 is equals to H2 is equals to H3. We are having layers of reservoir where the porosity is same. Porosity is different, but the thickness of the formation is same. In thickness weighted porosity, the thickness of the formation is layers is different, like it is H1, H2, H3, H4. The porosities are also different. So in order to get an average porosity of such formation, we generally do this one like this: 5.1 H1 plus 5.2 H2, similarly to 5n Hn by Hi, like H1 plus H2 plus something like this. And in case of aerial weighted, we'll be having a porosity. We'll be having a porosity in such a way that one layer with certain area will be having one type of porosity. Like for example, in this is a two-dimensional picture: 5.1, 5.2, 5.3, 5.4, and 5.5. So the average can be figured out in this way. Like similarly, if, in terms of area, it is based on area, right? So we generally take the parameter area and area. And if the volume, if we consider the in volumes, it is more accurate. So we'll be doing this like if HI is different with changing area, then we'll be considering volume weighted porosity. Yeah, this is up to this, and in the next video I'll be showing about the what are the different methods we generally follow to find the porosity. Thank you.